Hello friends, welcome to my YouTube channel. Today in this video tutorial we will learn one DSA problem which is taken from GFG POTD, Geeks for Geeks problem of the day. Today's problem is that given a matrix of order n cross m composed of only 0 and 1. Basically you are told that the matrix that are given is a rectangular matrix and all the elements of the matrix is either 0 or 1. Find the number of ones in the matrix that are surrounded by an even number of zeros. The surrounding of a cell in the matrix is defined as the elements above, below, left, right, as well as the four diagonal elements, that is northwest direction, northeast direction, southwest direction and southeast direction. All four diagonal elements around the cell of the matrix. Hence the surrounding of any matrix element is composed of 8 elements. Find the number of such ones. Basically problem में दिया गया है कि you are given the rectangular matrix in which you have to count the number of ones which are surrounded by even number of zeros, and surrounding means basically the one will be covered by zeros either in its upward direction, downward direction, left and right, and also its four diagonal, that is this diagonal, this diagonal, this diagonal, this diagonal for this element. So the problem is given in easy version. So and constant, you will see that time complexity is given because of n cross m. That is obvious because whenever you traverse the matrix you will have to traverse the row as well as column. That's why you have to take two nested for loop. So for that the time complexity becomes big of n cross m, and expected space complexity big of 1, that is space complexity. So we start the problem by typing the code. So our approach will be that for each element we basically count the number of zeros surrounded by this element, and after that, after counting the number of zeros surrounding that element, we'll check whether this number of zeros is even or odd. If even, then we increase the answer variable by 1 because we are told to count the number of ones, that is find the number of ones in the matrix. So let's begin the code. So at first I am taking an for loop, outer for loop, int I is equal to 0, I less than matrix dot size I plus plus. Then nested for loop for traversing the column of the matrix, as we are traversing the matrix in row wise fashion. So for int j is equal to 0, j less than matrix of I dot size j plus plus. Matrix dot size represent the number of rows present in that matrix, and matrix of I dot size represent the number of column that present in the ith row of the matrix given in this problem. So and we also take an answer variable to count that number of ones that satisfy the given condition that it is surrounded by even number of zeros. So initialize this answer variable by 0, and inside this nested for loop we take another variable, that is zero count, number of zero count, which is initialized by 0. So first we have to check whether the element is 1 or 0. If the element is 0, then there is no need to check the surrounding element for that 0, because we are given that we have to count the number of ones, so we will check only for ones. So we have to check, for that we will take one if a matrix of I j is equal to 1, then all the operation will be done on the matrix of I. So we will check the leftmost element of this matrix of I j, whether it is 0 or not. So now we will check whether there exists any 0 in the left of this matrix of I comma j element. So for that we will take another if condition, if j minus 1 less than equal to 0 and matrix of I J minus 1 is equal to 0. If both condition is true, then we increase the zero count plus plus. This is for left element of matrix IJ. Left element. Similarly, we will check for right element also, whether the element is 0 or not. For that we will check j plus 1 less than matrix of I dot size and matrix I comma j plus 1 is equal to 0. If this both two condition is true, then we increase the zero count. Similarly, we will do the same work for down element, that is bottom element, and above element of the matrix IJ. If I minus 1 greater than equal to 0 and matrix of I minus 1 J is equal to 0. If this condition true, then we will increase zero count plus below element I plus 1. As we are checking below element, that is for this particular element the below element is this one and above element this one for this particular element. Matrix dot size and matrix of I plus 1 j is equal to 0 count plus. Now we will check for four diagonal element. For any matrix element, it has four diagonal element. One is this element. For particular this element 1, it has four diagonal element, that is this element 2, 3 and 4. So we will check for 4 element. Northwest direction, for northwest direction diagonal element, if the condition like if I minus 1 less than equal to 0 and j minus 1 greater than equal to 0 and matrix of I minus 1 j minus 1 is equal to 0, then we will increase zero count. For north east direction diagonal, greater than equal to 0 and j plus 1 less than matrix of I dot size and matrix of I minus 1, because of j plus 1 element will be on the minus 1th row. Matrix of I minus 1 j plus 1 is equal to 0, then we will increase the zero count variable. Now for check another one diagonal element, southwest direction, Similarly we will do for southeast direction diagonal. Matrix of I plus 1 size and matrix of I plus 1 J plus 1 is equal to 0 count plus. As you can see that we have checked for left element, right element, above element and below element, and we also check for diagonal elements also. Northwest direction diagonal, northeast direction diagonal, southwest direction diagonal and southeast direction diagonal. So in each direction we have checked that whether there exists 0 or not. So after that we will check if 0 count is even or not. 0 count modular 2 is equal to 0 and 0 count greater than 0, then we will increase answer by 1. So finally we will return the answer. So now compile the code. All output is correct here. So now let's submit the code. Okay, you can see that my code is submitted successfully. So this was today's video. So if you like the video, then please do consider to share this video to all of your friends, and I hope you like this video also. Thank you friends, stay happy. Okay, bye.